We start with both of the shroud cars all the way forward. Then we're going to bring both sides to hand tight, being careful to make them roughly equal so that we keep the mast centered in the boat. A good way to check whether they're equal is to look at the distance between the threads. We started with the threads almost to the end of the body of the turnbuckle so that when we raise the mast, we would have no problem with excess shroud tension. We're going to use the method of using what's called a loose gauge here, and I've got the luxury of having 4 of them, so I can have 2 already in place on each side. If you're tuning by yourself, this is a big time saver. Otherwise, you have to keep going back and forth, as you'll see as we go through the process, to double check the tension on each side. There's an alternative, and the alternative is to actually, once your rig is tuned and you know where it's going to be, to simply measure the distance between these 2 studs with a micrometer. And in fact, these boats are set up that way. We do know what the distance is. And that allows you to make sure that the rig is centered each time and quickly get you to your tuning baseline. When we put up the mast, we actually attached the forestay, and it was already set up from prior launchings. This is one of the most important adjustments, however, because the forestay length is actually what determines the rake of the mast. So we knew that these were already set up properly and have not gone to the trouble of measuring this, but quite often you would do that. You take a measuring tape up to where the forestay attaches to the top of the mast, or where it attaches at the mast, and then you'd measure down to this point where the furler is and make sure that you've got this precisely correct. We already have that in place, so we can move on to the side shrouds. The Melges 20 is a bit unique in that it doesn't have a backstay. It does have these diamond stays instead, and they're actually the place to start adjusting. We want to take those up to a baseline. The measurement's 28 on the loose gauge. And we'll have to come back and readjust those, because as we tighten up the upper shrouds and then subsequently the lowers, it's going to change what the diamonds are. It also goes the other direction. If we over tighten the diamonds, that's actually going to change our other measurements. So we'll just take a look at this rig overall. So in this case, what we can see is that the diamonds, which started at the base of the mast, are actually going through this lower set of spreaders, and then they're carrying on through the second set of spreaders all the way up to the mast tip. The upper shrouds, on the other hand, are going through the first set of spreaders and then terminating just below the second set of spreaders, and that's also where the forestay attaches. And then the lower, you can see attached just below the first set of spreaders. So what's interesting about tuning this rig is that if one were to just focus on the uppers, for example, and ignore the diamonds, that would definitely allow there to be more mast tip movement than one might want. One of the handy things on the Melges 20 is this device here, which is a keeper really. It holds the shroud from twisting. We don't want to untwist or over twist this wire here. This is called diform wire. It's actually flattened on the outside, so it's a bit stiffer than normal 1x19. And then this turnbuckle has these, the body of it is actually got these little ratchets on it, so you can actually quickly make a turn, even on the race course. Something interesting we can notice is that actually by tightening the diamonds, the lowers got tighter. They were just hand tight a few minutes ago, and there's a reason for that. That's because if we think about the spreaders being swept aft and tightening up these diamonds here, that's actually going to bend the mast. And so this middle part of the mast where the lowers are attached is actually going to move forward as the mast bends. You can see how bent this one is. It's already fully rigged. So of course, if we move that forward, we tighten the lowers. But to start, we're actually going to ignore the lowers, and we're actually going to work just on the uppers and get those set. It turns out that's much more important and a lot easier to balance with the diamonds, and then come back and do the lowers as almost a last step, because they have very little impact on the other two, whereas the diamonds and the uppers have a lot of impact on the lower. This actually shows the set of tools that we can use. This upper tool acts to hold the shroud from twisting. The lower one we turn. In this case, look down from above, it's going to go counterclockwise to tighten. I went ahead and put 10 half turns in on this side only, and that brought it up to 32. I'm stopping short of my ultimate goal of 40 because of course I have to balance the two sides. So I'd really like to put equal turns on, maybe 5 or 10 at a time to start, and then less as we get closer to our ultimate numbers, but going back and forth to keep the mast in column side to side. I also know that as I go over to the other side and put on, let's say 10 half turns there to balance this, this number no longer will be 32, which it is now. It'll probably go up quite a bit. And I've just finished putting on the same number of turns on starboard, and it confirms that this did go from 32 up to 35. It's about what I expected. So I'll go ahead now and put another 5 turns on each side and see what we get. 5 more half turns actually brought us to around 38, 39. It's not exactly equal on both sides, so now I'll do a little fine tuning just to get us to 40. It's also worth taking a look at the threads here. Ideally what we'd like to do is put a coating on these threads to help them to move. We can also spray on something to both allow them to move more easily and provide some corrosion resistance. That would be a T9 product by Boat Shield. There's also a product called Lanacoat, which we could coat the threads with. The tensions on this boat are not so extreme that that's a major problem, but on large boats it is a major problem. And you can actually wreck the threads or gall the threads without properly coating them beforehand. So let's just take a look up our mast now that we've tightened the uppers on both sides to 40. We haven't changed the lowers, we're leaving those alone. But let's come back and see that there's a lot more bend in the mast than there was earlier, and make a prediction about what that's going to do for the diamond tension. As it turns out, it lowers the diamond tension. We went from being at around 28 to about 18. And that makes sense, because actually as the mast bends, the tip actually comes down. It takes the tension off the diamonds. If you think about the distance that the diamonds are now traveling, it's a little bit less actually with the middle of the mast going forward. But before we go ahead and tighten those diamonds, let's think it through. Maybe we should go ahead and take a look at the lowers, which are too slack. We ultimately want those to be up to around 30. They're only at 15. And here's why we should think hard about that. If we look at where the lowers are attached, if we tighten these lowers now, that's actually going to take some bend out of the mast and straighten it in this middle section. And as we do that, that's going to tighten the diamonds. So before we go cranking on the diamonds, why don't we bring the lowers roughly in the right vicinity of 30, and then we'll re-look at our diamond tension. Okay, so we brought the lowers now up to 30. It really hasn't affected our uppers much at all, if any. That's just because of how tight they already are, really. But it did affect, as we expected, the diamond. It got tighter, but it really didn't get as tight as we need it to be, so we're going to still have to add on some turns there. So this is what makes this an iterative process. You have to keep going back and forth to get to your end point. Okay, so I went ahead and brought the diamonds back up to 28. Let's just take a guess what might have just happened to our lowers. Based on the idea of the diamonds bending the mast more, you might expect that the lowers actually went. Finally getting there. So shows that once we've gone ahead and tightened the diamonds again, and again those are going all the way up to the mast tip, and by tightening those we've actually brought in some more bend into our mast, and we actually went ahead and took off some tension with the uppers. So we're going to make another fine tune of the uppers. So I went ahead and did a couple of 5 half turns on the uppers on each side, and that brought it up to 40 indeed, and we're getting close. As we get the rig under more and more tension, we're going to see less iterative process going on. So for example, the lowers really hardly changed. We're at about 31 there, And if we double check our diamonds, we went down from 28 to about 27. So we're really close. We're going to just fine tune those, make sure that everything ends up at what we want, which is 40 on the uppers, 30 on the lowers, and 30 on the diamonds. It should be said that this is actually a very heavier setting, relatively putting a lot of bend into the mast. We want to do this in this setting to support the masthead spinnaker, so we don't have our mast breaking in high winds, as there is no backstay. So as the last step, I just did a couple more turns and adjustments on the diamonds and the lowers, and now we are actually at a stable position. Let's take a look at the bend of the mast. So there's quite a bit of pre-bend in this mast. So we can measure this concept called pre-bend. What I've done is I'm holding the main halyard to the gooseneck. The boom attaches, and you can see where it's coming out of the sheave and the mast top, and the difference around the middle of the mast between the back of the mast, where the track is, and where this halyard is a measurement that we could take. This is probably about 7 inches actually, so that's quite a bit of what we would call pre-bend. And I'm just going to show you what, in a light air setting, maybe it might look more like that in terms of pre-bend, maybe 3 or 4 inches. So we've got it set up for a much more bent mast, and this actually makes the mast a more stable and stronger mast in big breeze. Of course, secondarily, it really dramatically affects the shape of the main sail and the tension on the forestay for the jib.